Another term that can be thrown around a lot in probability is the term compound probability. In this video, we're going to have a look into what compound probability is and how we can use compound probability in our calculations. So let's begin. Before we begin, let's define what compound probability is. Now, compound probability is the theoretical chance of two independent events occurring. Now, the concept of independent events is very important here, which is to say that each event is not influenced by another. For example, here I have three different coloured balls. I've got a red, blue and green. If I were to first select a ball completely at random, say I selected this red ball, I recorded its colour, then I wrote that down. After I did that, I then put the red ball back into the selection and at complete random again selected another coloured ball. We would consider this to be two independent events because when I selected the red ball the first time, it had no influence over my second selection within those balls. However, if I was to complete that same trial, except after I selected the first coloured ball, I did not replace it within the selection. I then selected a second ball. I could no longer select the red ball because I've already picked it in the first selection. So that means that the second event was directly influenced by the outcome of the first event. So these are not independent events. Now, I'll discuss more on probability with or without replacement in one of my future videos. But for now, let's keep with the example of selecting a ball at random twice where I replace it. If I were to draw a tree diagram of all the possible outcomes that occur, on the right here of this would be a list of these possible outcomes. So let's consider a couple of different probable outcomes. What if I wanted to know what the probability of getting a blue ball on the first selection followed by another blue ball on the second selection was? Well, I could start by counting the total number of successful outcomes here, which would only be the one, and list it at the top. Then count the total number of outcomes that could occur, which would be 9. And I'd find that my probability is a 1 in 9 chance. However, we can actually find this another way. We can actually find this probability of getting a blue ball followed by a blue ball by multiplying the probability of getting a blue ball on the first selection with the probability of getting a blue ball on the second selection. Now, if we break this down, the probability of getting a blue ball on the first selection is 1 in 3. And if we multiply by that, by the probability of getting a blue ball on the second selection, it is also 1 in 3. When we multiply these two values together, it gives us a 1 in 9 probability, which is what we found before. However, we didn't actually need to list the total outcomes here to find out this probability. Now, let's kick it up a notch. Let's say that we wanted to know the probability of getting a blue ball on our first selection, a red ball on our second selection, and then a green ball on our third selection, in this exact order. Well, we can actually find the chance of this by multiplying the probability of getting a blue ball on the first selection with the probability of getting a red ball on the second selection with the probability of getting a green ball on the third selection. If we work out what the chance of these are, the first one of getting a blue ball will be 1 in 3, multiplied the chance of getting a red on the second ball, 1 in 3, multiplied by the chance of getting a green ball on the third selection, which is 1 in 3. Now, if we multiply these values together, our numerator is still going to be 1. Our denominator is going to be 3 times 3, which is 9, times 3, which is 27. So our probability of getting a blue, a red, and a green in that exact order is 1 in 27. Now, it is important to understand that this will only work if you're calculating it for a certain order, and not the chances of getting a blue, a red, and a green in any order. So let's revise. Compound probability is the theoretical chance of two independent events occurring. Independent events means that the outcomes of each event are not influenced by the outcomes of any other event. We can calculate the compound probability by multiplying the probability of each successful outcome with each other. So now, why don't you give it a try? If you were to flip a coin and then roll a normal six-sided die, what would be the probability of getting a head on the first flip of the coin, followed by an even number on the die? Remember, once you give it a shot, you can check your answer by completing a tree diagram that lists all the possible outcomes for this event.